Hi guys, myself Nishad. Welcome to another session. In this session, we are going to discuss about source-free RC circuits. Source-free circuit means when a source, either voltage source or current source, is removed from the circuit suddenly, then it becomes a source-free circuit. So we are going to discuss the transient behavior of a source-free RC circuit. Now, consider a source-free RC circuit. We have a capacitor and a resistor. Since this is source free, there is no voltage source or current source. Let the value of resistance is denoted by R and capacitance be C. Now let the initial voltage across the capacitor be V0. Okay, V0. Now since the C and R are in parallel, so the voltage across this element is denoted by small letter V. Okay. Now consider a node. Let this is denoted by A, point A. The voltage at this node is V of t, indicated by V of t. Okay. Now consider the circuit. This V of t is the voltage at this node. Now we are going to apply KCL at this node. That means apply KCL at node A. So we can denote all the current is outgoing. Let the current through the capacitor is denoted by IC and current through the resistance is denoted by IR. Now we are assuming all the currents are outgoing. IC plus IR is equal to 0. Now, current through the capacitor is given by C dV by dt and current through the resistance is given by V of t divided by R. This is equal to 0. Now, we can write dV by dt is equal to minus V of t divided by RC. I am taking this C into RHS. Now this is equation number 1. We can manipulate this equation as dV by V, that is equal to minus dt divided by RC. Now integrate both sides of the equation. While integrating the LHS, we will get ln V and the integration of RHS become minus 1 by RC into T plus constant of integration, that is denoted by K. Now our initial condition is when T is equal to 0, the voltage across this capacitance is given as V0. That is at T is equal to 0, voltage across the capacitor VC0, that is equal to V0. Okay, now putting t equal to 0 in this equation, we get ln V, that is equal to K. V is equal to V0, or constant of integration K is equal to ln V0. Now this equation become ln V is equal to minus 1 by RC into T plus ln V0. This term is taking into the LHS. So this become ln V by V0, that is equal to minus 1 by RC into T. Or this can be written in exponential form as V by V0 is equal to e raised to minus T by RC. Or this implies the output voltage, the V of t, the voltage across this capacitance and resistance is equal to V0 into e raised to minus T by RC. Okay, this is the expression for finding the voltage. Now, this can be written as V of t is equal to V0 into e raised to minus T by tau, where tau is equal to RC. It is called time constant of the network. Time constant of the network. Its unit is second. Okay. If in a circuit it consists of more than one resistance, then this R is equal to equivalent resistance or Thevenin's equivalent resistance. In such cases, R is equal to R equivalent resistance if a circuit consists of more than one resistance. And this is equal to R Thevenin, that is a Thevenin's equivalent resistance. And time constant tau is equal to RTH into C, this much second. Now, we can draw this response V of t is equal to V0 e raised to minus t by tau as, okay, this is a figure of representation of V of t, that is equal to V0 e raised to minus t by tau against time in second. At t is equal to 0, the value of V of t is equal to V0. I am marking this as V0 as t is equal to 0. And this is an exponentially decaying curve. So this curve exponentially decaying and finally comes to 0. Now, when t is equal to tau, t is equal to tau, then V of t is equal to V0 into e raised to minus tau by tau. Minus tau by tau means minus 1, e raised to minus 1, or that is equal to V0 by e. So that is reduced by a factor 1 by e, or this is equal to 0.368 V0 or 36.8% of V0. Okay, this is my percentage. When t is equal to tau, the response becomes 0.368 times V0. So time constant tau is defined as, it is a time taken for the response to reduced by a factor of 1 by of its initial value, or the time required for the response to reach 36.8% of its initial value. That is the definition for time constant of the network. For the circuit, current through the circuit is V of t divided by R. Now we know that V of t is equal to V0 into e raised to minus t by tau. This divided by R. This is the current through the circuit. So current is also exponentially decaying. But the initial magnitude of the current at t is equal to 0 is V0 by R. So this is the shape of the response I of t. And the initial current that is given as V0 by R. So this is exponentially decayed to 0. When t is equal to 5 times the time constants, the current and voltage approaches to 0. Okay. Now, what is the power? We know that power P of t is equal to V of t into I of t. That is equal to V of t is V0 e raised to minus t by tau into I of t, that is equal to V0 into e raised to minus t by tau by R, or this is equal to V0 square by R into e raised to minus 2t by tau. This is the power absorbed in the resistance. Okay, that is power dissipated in the resistance. Now, based on this fact, we have to do some problems. Now, consider an RC network, a source-free RC network. We have a resistance here, another resistance, and another resistance is connected to this node, and a capacitor. Okay. The values of this resistance and capacitance are, let this be 12 ohm, this resistance be 6 ohm, and this resistance be 8 ohm, and this capacitance be 1 by 3 farad. Okay. The capacitor have an initial voltage V0 that is given as 15 volt, that is VC0 is given as 15 volt. Okay, question is to find VCT at t is equal to 2 seconds. Okay, this is a question. We want to find the value of this voltage at t is equal to 2 seconds. Choices are given. A is given 12 volt B is given 13.62 volt and C is given 2.04 volt and D is given 9.09 volt. Okay, now we know that VCT, that is a voltage across a capacitor, is equal to V0 into e raised to minus t by 2. Where V0 is the initial voltage across a capacitor. That is a voltage at time t is equal to 0. That is given as 15 volt in the question. Now we want to find tau. Tau is equal to R equivalent resistance or RTH into C. Now what is RTH? For RTH, for finding RTH, we can use the Thevenin's equivalent circuit. This is our Thevenin's equivalent circuit and this is our RTH. The value of this resistance is 8 ohm. This is 6 ohm and 12 ohm. This 12 and 6 are in parallel. 12 parallel to 6, that is in series with 8, that is plus 8. So 12 into 6 divided by 12 plus 6 plus 8. That is 12 into 6 divided by 18 plus 8. This becomes 3. This becomes 3 times 4. 4 plus 8. That is equal to 12 ohm. And C is equal to 1 by 3 farad. So time constant tau is equal to 12 into 1 by 3. That is equal to 4 seconds. So this is our time constant. Now V of t or Vc of t, that is equal to V naught. That is 15 into e raised to minus t by tau. Tau is 4. Now we want to find the value of output Vct at t is equal to 2 seconds. So put t is equal to 2. So Vc2, that is equal to 15 into e raised to minus 2 by 4. The value can be found as 9.09 volt. So D is the correct option. Now for the same circuit, let the voltage across this resistance is given as Vx. Okay, so that indicates the voltage at this node is Vx. Now we want to find the voltage Vx at t greater than or equal to 0. That is, find this voltage Vx for t greater than or equal to 0. So we can denote this by Vx of t as a function of time. The choices are given. A, Vx is equal to 5 into e raised to minus 40 volt. Choice B, Vx is equal to 12 into e raised to minus 0.25 t. This much volt. And choice C, Vx is given 5 into e raised to minus 0.25 t volt. And choice D is given 15 e raised to minus t volt. Okay, now apply KCL at this node. Let this node be A. So we are assuming all the currents are outgoing currents. Okay, so this current plus this current plus this current is equal to 0. So current through this resistance 12 ohm is given by Vs by 12 plus current through this 6 ohm resistance, that is Vx by 6 plus current through this branch, that is given by Vs minus Vct divided by 8, that is equal to 0. The voltage across this capacitance, that is given as Vct. So the potential difference across this branch, this 8 ohm resistance, is Vx minus Vct. Now take the LCM. This becomes 2Vx plus 4Vx plus 3 into Vx minus Vct. This is equal to 0. Okay, or 2 plus 6, 6 plus 9. 9Vx is equal to 3 times Vct, or Vx is equal to 3 by 9 Vct. That is equal to 1 by 3. Vct we have already found as 15 into e raised to minus t by tau. This is our VCT. So this is equal to 5 into e raised to minus t by tau. Our tau is 4 second 4. So this is equal to 5 into e raised to minus 0.25 t. This much volt. That is the voltage across this resistance. So our choice is B. This is the right answer. Okay. Consider a circuit. Okay. This is a battery source of 20 volt. And we have a switch. This switch is open at t is equal to 0. The switch is open at t is equal to 0. So before t less than 0, the switch remains closed. Now we have another resistance connected like this, and another resistance and a capacitor. Okay, this is our circuit. The values of resistance and capacitors: 3 ohm, 9 ohm, 1 ohm, and 20 millifarad. The voltage across a capacitor is indicated by VCT. Okay. Now the question is, we want to find the voltage across the capacitor VCT for time t greater than or equal to 0. From this question, the switch is opened at t is equal to 0. So the switch remains closed for all time t less than 0, and this capacitor gets charged. At t is equal to 0, the switch is open. So this portion of the circuit is removed. Then we have capacitor have some charges, and capacitor will discharge through this resistance 1 ohm and 9 ohm. So that is the condition. So choices are given. A is given 15 into e raised to minus t volt. Choice B is given 12 into e raised to minus 0.2 t. Choice C is given 15 into e raised to minus 5t, and choice D is given 12 into e raised to minus 5t. These all are in volts. Okay, these are the options given. So for t less than 0, the circuit remains closed. So the circuit is in steady state condition. So we can redraw the circuit for this condition as we have a voltage source of 20 volt, and this is 3 ohm resistance, and the switch remains closed, and this resistance. Okay, resistance. Since under steady state condition, the capacitor become open circuit. That blocks DC. So the capacitor is replaced by an open switch. So no current flows through the circuit. Current flows this circuit is equal to 0. And this is our plus or minus voltage across this 9 ohm resistance. This is equal to VC 0. This is same as this branch is parallel. So the voltage across this capacitor also is equal to VC 0. That is a voltage. VC 0 is a voltage across this 9 ohm resistance. This since no current is passing through, so the voltage across this open switch is same as the voltage across this 9 ohm. Now what is the voltage across 9 ohm resistance? That is equal to, we can find this voltage. This current is equal to, I is equal to 20 divided by this resistance is 3. 3 plus 9. That into this resistance will give the voltage across this resistance at time t is equal to 0. That is 0, t equal to 0 minus. That is VC0 minus, that is equal to 20 divided by 12 into 9. That is equal to, this become 3 times, this become 4, 5. That is equal to 15 volt. That is the voltage across the capacitance before the switch is open. So we can say VC0 minus is equal to 15 volt. Since the voltage across the capacitor cannot be changed instantaneously, that means VC0 minus should be equal to VC0 plus. So this is the voltage across the capacitor at T is equal to 0 plus when the switch is open. Since voltage across the capacitance cannot change abruptly, this is our voltage across the capacitor, that is equal to Vc0 plus, that is equal to 15 volt. Now at T is equal to 0 plus, we can draw the circuit as this is our circuit at T equal to 0 plus. So this portion is removed. So the capacitor will discharge like this. This is plus minus, capacitor will discharge. So we have only this portion of the circuit and we want to find VCT. And we know that VCT, that is equal to Vc0 plus, that is the initial value of voltage across the capacitor, into e raised to minus t by tau, where tau is our time constant and tau is given as R equivalent, that is R equivalent is 1 plus 9, that is RTH into C, RTH, that is equal to 1 plus this 9 ohm, that is equal to 10 ohm. So tau is equal to 10 into C, C is 20 millifarad, that is 20 into 10 raised to minus 3 farad, that is equal to 0.2 seconds. Okay, this is equal to 15 into e raised to minus t divided by 0.2, that is equal to 15 into e raised to minus 5t. So our option is C. C is the answer. Okay. Now, for the same question, they are find the initial energy stored in the capacitor. That is, find the initial energy stored in the capacitor. Energy stored in the capacitor. Okay. Choices are given. A is given 4.5 joule. B is given 0 joule. C is given 2.25 joule. And option D is given 10 joule. These are the 4 options given. And we know that initial energy stored in the capacitor, that is equal to half C Vc square. Vc means the initial voltage across the capacitor. That is equal to half into capacitance value is 20 millifarad, that is 20 into 10 raised to minus 3, into initial voltage across the capacitor is 15 volt, that is 15 square, that is equal to 2.25 joule. So the solution is C. In the next class, we will discuss about source-free RC circuit. After that, we will discuss the transient behavior of RLC network, that is including sources. Okay, thank you. Bye.